Hello, students. Welcome to the online session of chemistry. Hope you all will enjoy this e learning. So, we will begin with the first chapter. Welcome to the chapter Matter in Our Surroundings. This is an overview of the chapter that we are going to learn. At the end of the chapter, you will be able to particles of matter, explain the states of matter, identify the shapes and volume of solids, liquids, and gases, list out the characteristics and properties of three states of matter, discuss the diffusion of states of matter, explain the force of attraction between the particles of matter. We have studied in lower classes about metals and non-metals, synthetic and natural materials, acids and bases, etc. Do you know all the metals and non-metals, synthetic and natural materials, acids and bases are examples of matter? Water we drink, food we eat, air we breathe, clothes, and various other things that we use in our daily life are examples of matter. Let us know more about the concept of matter scientifically. Matter. In a simple way, anything in this world that occupies space and has mass is considered as matter. Everything in our world is made up of matter. The scientists work on stuff. Even the air around us is matter, although we cannot see it. All the things around us which exist in a variety of shapes, size, and textures is matter. There are three states of matter called solids, liquids, and gases. Matter can be changed from one state to another, like solid to liquid or liquid to gases. Let us discuss nature of matter. Nature of matter can be understood based upon its properties and composition. Physical nature of matter. The nature of matter can be determined by studying its properties and composition. The physical properties of matter basically means its color, smell, density, melting point, and boiling point, etc. Let us perform an activity to find out whether matter is particulate or continuous. Take 100 ml beaker, pour 50 ml water in it. Mark the level of water with a marker. Now add 2 grams of sugar in the beaker and stir it with a spoon till all the sugar gets dissolved. Observe any change in water level. We will observe that the level of the water in the beaker is at the same mark after dissolving the sugar in the beaker. That is, the level of the water does not changes, it remains to its initial position. So, from this activity, we learn that even after dissolving 2 grams of sugar in 100 ml of water, the volume has not increased. When we dissolve sugar in water, the particles of sugar get into the spaces between particles of water. In the same way, dissolving sugar in water tells us there are spaces between the particles of water. Characteristics of particles of matter. The following are the important characteristics of particles of matter. That is, the particles of matter are very, very small. The particles of matter have spaces between them. The particles of matter are constantly moving. The particles of matter attract each other. We'll find out all these properties with activity later on. States of matter. Water can be found in all three states. Because of this, we can say that solids, liquids, and gases are three different states of matter. Solids have certain size, shape. In solid state, the constituent particles are closely, regularly, and tightly packed, as we can see. In the same way, the particles cannot move around much, but these particles only vibrate in fixed positions. Liquids. Liquids have a definite volume but no definite shape. In this state, the constituent particles are not together closely. For example, milk is a liquid. It has a size, volume. Volume means it takes up space. But milk does not have any definite shape. Gases. Gases have neither a definite shape nor a definite volume. In this state, the constituent particles are far apart and move freely. In physics, a state of matter is one of the distinct forms that matter takes on. Each of the state is also known as phase. Elements and compounds can move from one phase to another when specific physical conditions change. Let us perform an activity to find out the shape and volume of liquids. Collect different containers of various shapes like beaker, conical flask, and cylindrical jar. Take some water in a glass, pour the same amount of water in each container. Mark the level of water and observe their shapes. Repeat the same process with milk and oil. Now observe their shapes. In this activity, we observe that liquids take different shapes based on the container, whereas the volume remains the same. So we can conclude that liquids have fixed volume but they do not have fixed shape, and that is why liquids are also called fluids. Let us understand shape and volume of gases. For example, we know that compressed natural gas or CNG is a natural gas under pressure which remains colorless, odorless, and is non corrosive. CNG comes into the filling station by the natural gas pipeline. The station has a compressor unit that compresses the natural gas. From these observations in daily life, we find that CNG and all other gases neither have fixed shape nor volume. Compressibility of different materials. Let's understand with this activity. Take a 100 ml syringe. Draw the piston to suck in air. Now put your finger on the nozzle. Now press the piston. Observe the depth to which piston moves into the syringe. Repeat the same procedure with water and sand. Similarly, observe the depth which piston moves into the syringe. Similarly, observe the depth to which piston moves into the syringe. Observation. From the above observation, we find that gases are highly compressible as compared to liquids and solids. We learned that mostly gases are used for cooking and in automobiles. For cooking, we use LPG gas. In all these purposes, large volume of gases is compressed into cylinders of smaller volume to make them portable. Observing the diffusion of gases. Take some incense sticks and smell their fragrance. Place them in any corner of the room. Light the incense sticks. Try to smell their fragrance from a distance. In this activity, we observe that when we light the incense sticks, the scent in the vapor form and smoke mixes with the air and moves across the room to reach our nose. Finally, we learned that the movement of air, vapor of scent, and smoke is known as diffusion. In this case, smoke, vapor of scent, and air are highly mobile and are in the form of gases. Let's observe the diffusion of liquids with an activity. Take two beakers, fill them with water. Now take potassium permanganate crystals. Add some crystals of potassium permanganate in a beaker. Take a dropper. Now add a drop of potassium permanganate solution slowly along the sides of the other beaker. Observe the changes. In this activity, we observe that the particles of potassium permanganate and water spread and mix up with each other on their own. Finally, we learn that the particles of potassium permanganate and water move. Therefore, we can conclude that liquids also diffuse with each other like gases. Diffusion of solids, liquids, and gases. We know that solids and liquids diffuse into liquids and gases diffuse into gases. Certain gases from atmosphere, particularly oxygen and carbon dioxide, diffuse and dissolve in water and support the survival of the aquatic animals and plants. Diffusion, therefore, is a very important process for living things. Oxygen diffuses from lungs into blood. Carbon dioxide also diffuses from blood into lungs. Solids, liquids, and gases diffuse into liquids, and rate of diffusion of gases is higher than that of liquids and solids. Can matter change its state? We all know from our observations that water exists in the three states of matter, that is, solids as ice, liquids as the water, and gases as water vapor. We must have seen many other materials that can exist in different states. For example, coconut oil is usually liquid in state, but in the winter season it is too cold and it becomes solid. Similarly, camphor is a solid, but if we leave it in the open air for some time, it changes to gas. Solids and liquids are the different states of matter, but properties of different matter in different states are different. This is because all matter is made up of tiny particles. How small are the particles of matter? Let us understand with an activity. Take a beaker, fill it with water. Now take potassium permanganate. Add some crystals of potassium permanganate in a beaker. Now take out approximately 10 ml of this solution and add it to 90 ml of clear water in another beaker. Once again, take out 10 ml of this solution and add to the 90 ml of clear water. Carry out this process 3 or 4 times and observe the changes in the color of the solution. We observe that the solution remains colored even when highly diluted, but the color of the solution decreases with dilution, that is, its intensity decreases. Finally, we conclude that there must be several tiny particles in just one crystal of potassium permanganate, which gets uniformly distributed in water to change its color. Particles of matter attract each other. Yes or no? We'll try to find out. Take a beaker, fill it with water, mark the level of water, add some salt to the water, stir it thoroughly with a spoon, observe the changes. Once again, add some more salt to the water and stir it. Now observe the changes. Here we found that the levels of water changes. Let's move to another activity. Open a water tap. Now allow the water to reach the ground. Now try to break the stream of water with finger. Release the finger after few minutes. Observe the changes. Here we observe that water flows with more velocity when it's than its normal velocity for a few seconds after the finger is released. Later on, the water reaches its normal velocity. Similarly, we observe that the forces of attraction between particles are the maximum in solids, intermediates in liquids, and minimum in gases. So finally, we learn that both solids and liquid particles have some spaces between them. The solid particles enter into the spaces between the liquid particles with solids dissolved in liquids. We also learn that the particles of matter have forces acting between them. Keep the particles together. It is also clear that the forces are not equally strong in all forms of matter. Diffusion of matter. The intermixing of the particles of two or more different substances on their own is called diffusion. In the intrinsic activity, the particles responsible for scent move and enter the space between the air particles. The scent particles quickly spread across the room. The rate of diffusion of gases is very high because the particles of gases travel with a very high speed. Rate of diffusion of gases is higher than liquids while the rate of diffusion of liquids is higher than solids. There are two reasons for the higher rate of diffusions of gases. One is due to the higher speed of the gaseous particles, another one is due to the great space between them. Similarly, liquids have greater diffusion rate than solids because particles in liquid move freely and have greater space between them when compared to the particles of solid. As we can see, the arrangement of particles in solids, liquids, and gases. The diffusion of solid into another solid substance is negligible due to the immobility of the particles in solids, while the diffusion of liquids into another liquid and that of a solid into a liquid is much slower than the diffusion of gases into gases. At the same time, the diffusion of gases is very high. Let us discuss the effect of temperature on change of state. Solid to liquid. Let us perform an activity where a solid is changing into liquid state. Take a beaker filled with small ice cubes. Insert a thermometer into the cubes. Observe the thermometer reading. Now put the beaker with the ice cube on a burner with the help of a tripod stand and start heating the beaker. Then the ice cube starts melting. Observe the changes in the thermometer reading for every 1 minute until all the ice melts. In this activity, we observe that the temperature of the mixture of solid ice and liquid water does not change for some time. It changes only when it reaches a specific temperature. The temperature which starts changing only when ice completely melts. Finally, we learn that at a certain temperature, the solid melts and changes into liquid. The temperature at which a solid melts into liquid is called melting point, and the process is known as fusion. Let us understand the effect of temperature on liquids. Take a beaker and pour some water in it. Place it onto the burner with the help of tripod stand. Measure the temperature of the water with the help of thermometer and note down the readings for every 2 minutes. Observe that the temperature of the water increases continuously till it reaches 100 degrees Celsius. In this activity, we observe that water boils to steam when the temperature reaches 100 degrees Celsius. This shows that particles in water vapor at 100 degrees Celsius have some more energy than the particles in liquid at same temperature. Finally, we learn that at a certain temperature, the particles have enough energy to become free from the forces of attraction among the particles and liquid starts changing into gases. The temperature at which a liquid starts boiling at the atmospheric pressure is known as boiling point. Boiling point of water is 100 degrees Celsius. Let us discuss some very important definitions, that is latent heat of fusion, latent heat of vaporization, and anomalous expansion of water. So, latent heat of fusion, the heat required to convert 1 gram of solid completely into liquid at a constant temperature is called latent heat of fusion. Consider a solid of mass m which converts from solid phase to liquid phase when heat Q is supplied to it. The heat required to convert 1 gram of solid into liquid is Q by m. Latent heat of fusion L equals to Q by m. The value of the latent heat of fusion of ice is 80 calorie per gram. Latent heat of vaporization. Heat required to change 1 gram of liquid to gas at constant temperature is called latent heat of vaporization. The latent heat of vaporization is given by the expression Q by m and it is denoted by L. The SI unit and the CGS units of latent heat of vaporization is joules per kg and calorie per gram respectively. Anomalous expansion of liquids. A liquid usually expands when it is heated, but water behaves differently between 0 degrees Celsius to 4 degrees Celsius. Its volume shrinks. Same amount of water in solid ice occupies more volume than liquid water. We say that water expands from 4 degrees Celsius to 0 degrees Celsius if it is freezed. This is an anomalous expansion of water. The density of ice is less than that of water at these temperature and this is the reason why ice floats on water. Effects of change of pressure on matter. We know that water exists in three different states, namely solid, liquid, and gases, which are otherwise known as ice, water, and vapor. Top of high mountains and Arctic and Antarctic oceans have water in form of ice, that is snow. Oceans, rivers, and lakes have water in the form of liquid. The vapors from water is present in the atmosphere. Steam is absorbed when water is boiled. We also make ice using the special sections given into the refrigerators. It is important to note that the three states of water are interchangeable. When water is boiled, steam is observed. On the other hand, when steam is cooled, water is obtained. On heating ice, it changes into water. If water is cooled below 0 degrees Celsius, we get ice.